In this STEMinar episode, we will be joined by Olivia VanDamme, who is the Education Program Coordinator for Science Action Club. She has 5 years of experience connecting youth to nature as an environmental educator. She is passionate about expanding access to STEM and the outdoors to Black and Indigenous people of color. As an experienced facilitator, Olivia is also inspired by supporting other educators in their professional development journeys. With Science Action Club, Olivia helps with data management, enrollment, and supporting programs with STEM learning nationwide.
Hello, everyone. Thank you so much for joining, and thank you, NC CAP, for hosting me. My name's Olivia, and I'm excited to teach you more about Science Action Club and a specific activity called Sky Survey. Science Action Club uses a really amazing protocol that gets you excited and interested in things about the outdoors and nature and our natural world. And we use a protocol called citizen science, which is really awesome ways to contribute your observations of the natural world to bigger research questions that scientists are asking. So what exactly is citizen science? Citizen science is also known as community science, and it's a global movement in which scientists and the general public collaborate to answer some of the most pressing questions about our planet. Many questions that scientists have require more data than one scientist could collect themselves. And citizen science is an amazing way and an avenue in which many people can contribute their observations to a global database. And Science Action Club chose to use citizen science for our curriculum to really have youth practice their STEM skills, build their STEM identity, and really contribute and know that their work as authentic scientists can start right now, and it can be done anywhere, anytime. We really want our curriculum to be accessible to many different communities, and we chose citizen science because it has this really unique way of bringing more people together in community and having connection between and across different geographies, knowing that you're contributing to this global effort of trying to answer these questions about science. So in CloudQuest, we explore the impact of clouds on weather and climate. Using our Globe Observer citizen science platform that was developed by NASA, youth identify sky conditions and they report their observations to NASA. Researchers use these observations with satellite images to study how clouds influence our Earth's atmosphere. So CloudQuest is one of our units that we're going to dive into today, and we're really excited to show you the citizen science protocol that you need to know in order to submit a sky survey using Globe. So the Globe Observer app is really amazing, and we want to kind of walk through this with you. It's really exciting to get to share this with you all today, and maybe you can bring this to your program, to your family, to your friends, and your community. This is something that many people in all different ages can do and collaborate together. And science is all about collaboration. So we will look at the Sky Survey protocol, and it's on our program page that's linked below. And I know we'll have the link right in the description or in this video for you to access our program page, and you can just go to the CloudQuest section and find our Connect to NASA activity, and that will have our step-by-step guide as well as I'm walking through this today. So we'll walk through what you need to complete your first Sky survey for an in-person learning environment and also a virtual learning environment. We know that many programs and many youth have needed to shift and adjust this past year to learning online. And our curriculum is really ready to adapt to an online virtual environment. And I really want to show you that today as well. And if you're still in person and doing social distancing and have to follow health protocols in your community, then there's ways to still do sky observations as a group in a safe way. And for those of you that are doing hybrid learning, where you're doing a little bit of both, maybe there's some activities that you can practice online and some that you can do in person, like the citizen science part. So there's some steps and protocol needed to submit your Globe Observer and provide data to NASA. And I'm going to go ahead and introduce some of these tools that are needed. And then you can practice from your window, from your porch, from your backyard, from your street. And that's a really cool thing about this too. You can make observations of the sky from almost anywhere that you can see the sky. And so we really want you to feel encouraged and inspired and ready to make these sky survey observations. So let's go practice our STEM skills. All right, so we will cover first how to adapt a sky survey for a virtual environment. So we're going to focus on 2 out of the 4 tools needed for a sky survey. The cloud cover grid on the left, and then the sky color strip is on the right. We won't be using the Globe app right away for this practice since it's not an outdoor observation. We're going to do an online Zoom observation. And so we'll focus on practicing our science skills and our observation skills and some math skills, which are all part of STEM. So let's go ahead and get started and look at an image of a beautiful sky, some awesome clouds right over a body of water. So this piece is just a way that you can pull up an image of clouds and a sky observation. So you can go ahead and use an image like this from the internet, or you can take an image from your site and upload it to your presentation and then have your group or look over what these are, what these clouds are. So first, using the cloud cover grid, we're going to imagine it's an 8.5 by 11 piece of paper. So that's a typical printer size piece of paper, and it has these grids in it with different squares. And so this grid has 20 squares, and we're going to place it right over the sky. So here we're placing this grid over the sky, and we're going to look at the cloud cover for the low sky. And we can see that those clouds are in the lower part of the altitude of the sky. And we want to get a snapshot and look at and imagine that if all these clouds are visible to us, if they're all smushed together, how much of the sky do they cover? So we're trying to figure out a percentage. So Diana, how can you look at these clouds and decide how much of the sky is covered here? How many
So,
boxes do you think?
looking at the picture, if we were to clump them all together, I would say around like 4 or 5 boxes.
Awesome. And how many, so some of them, are they all the way filled up?
No, some of them have very few clouds in them,
Awesome.
and some of them have a lot.
Yeah, definitely. So that box in the middle has a lot of clouds, like basically filling up that entire square. But then those boxes on the bottom right, they have very few clouds kind of showing in those squares. So now thinking about the 4 or 5 that you're observing here, now we need to convert that to a percentage. So how many, if 4 or 5 out of 20, how much of a percentage would that be for the whole sky?
Like 25%, roughly 20% ish.
Yeah,
I don't know.
definitely. Awesome. So this is a really cool way to practice our math skills and converting, fractions into percentages. So we can practice and look, and when we're looking in the sky with this box, sometimes I even like to use a dry erase marker because the sheet that I have is like a clear through plastic sheet, and I can kind of mark or fill in those boxes, and then use that when I bring it back down and try to calculate how many of my squares are filled with clouds, because some cloud formations aren't as simple as this, right? We have some clouds when we look up, they look really complex, and there's all different types, and they can really fill the sky in different pieces, and there'll be some of the blue sky coming through. So this is really cool to practice these skills of really trying to observe and guess and make your best scientific analysis on percentage of cloud cover. All right, so next we're going to look at sky color, which is really cool. So we're going to hold the sky color strip and just put it onto this slide as well. And we will look at this, the deepest part of the sky. So the deepest color of the sky is where we want to make our final um, our final observation, is looking at the deepest color of the sky here. So can I have a volunteer kind of tell me which part of the sky and which color do you think the entire sky is? What do you think the color of this sky in this photo is?
Um, I think the color is the deep blue. I would pick the very top, specifically the top right of the sky. It's really, really dark, so I would pick the deep blue color as that part.
Awesome. Yes, I agree. I think this sky is definitely deep blue, or maybe even darker than deep blue. And so in this sky color strip, we have that deep blue, blue, light blue, pale blue, and then milky. Have either of you ever seen the sky when it's milky, that milky color?
Yes.
Yes.
I think I have that milky color right now for me.
Oh, awesome. Great. Great observations. Yes, it's really interesting to see the sky change color over time. And this can be one of our best practices as STEM educators and as facilitators is connecting to prior knowledge. So we really want to ask youth about their previous experiences and really tap into what they already know about clouds, what they already know about sky color, and really encourage them and let them know that their knowledge is super important to this type of work, and that they already have the skills that they need from practice, and we can just continue practicing these two tools of cloud cover and sky color. All right, so let's recap. We looked at this cloud cover grid and we looked at our sky color, and we got some really awesome practice with both of those. And congrats, you're all our citizen scientists, and we all basically work for NASA now. So this is a really exciting and component of our STEM curriculum, is really getting youth excited about these skills. And imagine if we had like 10 more slides where you can just keep practicing, okay, how many percentages or how many squares are filled with this image, and what's the sky color here, and you can share variation and different ways of really practicing these skills and really honing in on that, so that when you're ready to do an outdoor activity with this curriculum, you can all be really practiced, and your students will feel so confident in their skills and ready to go outdoors and say, oh, I got this. I have this cloud covered grid. I know this skill, and I can make this observation. Awesome. All right, so for doing an outdoor observation, there will be 4 tools you'll need to complete the sky survey. And again, these will all be linked, all these tools will be linked below, so that you can access these tools digitally. You can print them out at home, or you can use them on your computer or on your device, on your phone. And these tools are totally accessible and free to use for this sample activity on our website, as well as linked below. So the 4 tools are Cloud Cover Grid and Sky Color Strip, which we covered before. And now we're going to add the sky survey chart and the sky survey sticker. So the sticker is on the left, and the sticker is a way to track and really keep notes of all your sky observations. So for uploading your observations, you will also need to create a Globe account. Please make sure you have an adult help you with this piece to make your own Globe account through the app. Linked below is also a guide on how to create your Globe account on your device. So there are some step-by-step instructions on how to make a login, how to log in, and how to find this application on your device. So you'll first need to record the location, time, and date on the Sky Survey sticker. So can I have a volunteer, again, just share where's your location and what time is it and what's the date today?
I am in Raleigh, North Carolina. It is 12:32, and it is March 4th, 2021.
Awesome. So we'll go ahead and put that. You can see where we put that up in the top left column or row across of those really important pieces. When we're gathering data as scientists, it is really important to mark our date and time and where we're at so that we know exactly where we are making these observations, and other scientists can use that data to really help with ground truthing and with the satellite images. So next, we're going to keep that Sky Survey chart handy because the Sky Survey chart really helps walk through each of those steps. And so, Diana, earlier you said about 20% of the sky was covered in clouds. And so, looking at the Sky Survey chart and under this cloud cover section, what would the description be for that percentage?
Yeah, so I would say that it was sort of scattered, or yeah, I would say scattered.
Scattered clouds, this is why the sky survey chart is really helpful, because once we make those observations like step by step, then it kind of helps us mark and follow along with, we see the cloud cover and the sky color. And there's a couple more pages to the sky survey chart. All right, so let's go next to the cloud cover grid, which we already learned about. So we're going to use that now. We're going outside or to our window or to another location in our neighborhood to go ahead and make this observation. So we'll use that cloud cover grid to estimate the cloud cover outdoors, and those are in the categories of few, isolated, scattered, broken, or overcast for the entire sky. And so when using this cloud cover grid, we want to identify clouds at 3 different altitude levels. So we practiced looking at the low altitude, then we want to look at middle altitude, and then high altitude. And so we want to keep using that math practice of converting how many boxes are filled with clouds and converting it to a percentage. And observing clouds at different altitudes can take practice. And clouds might seem like they all will be the same distance away, but some are actually closer to the Earth's surface and others are higher up in the sky. And this can take a lot of practice. So don't feel discouraged if there's so many different clouds and they're kind of layered on top of each other. That can be a really difficult day to make observations at 3 different levels. And so the closest ones might block the view of the higher ones because of the different altitude that they are in the sky. So if you've ever been in an airplane, as you're rising up in altitude, you see different layers of the clouds as you go up in altitude. And so when you're standing on Earth and looking up, you're kind of seeing it from a different angle than when you're in an airplane. And on a clear day, kind of only on a clear day, can we actually estimate cloud cover for all 3 altitudes, because you want to see, all the the way the sun and how clear it is can kind of determine if you're able to make that. So next we'll do the sky color, and when we're outdoors making an observation, we actually want to place our back to the sun, and then we want to hold the strip at a 45-degree angle, comfortably raising your arm, and use the sky color strip looking up at the sky with that sky color strip. All right. So those are a couple more, information about the protocol here. And then we're going to finish filling up your sky survey sticker and then open up Globe. So Globe is the app that we're going to use, and we're going to put all the data from our observation. And then within the app, it'll prompt you to take photos of the sky. And it's really fun because you get to go into all the different directions. So you get to go north, east, south, and west and take images of the sky. And congratulations! That is the way that we do our NASA Sky Survey. And you just completed your first sky survey as a citizen scientist. Yeah! All right. So how to connect more with Science Action Club? You can learn more at our program page, which is calacademy.org/SAC. And we have many other activities that you can sample, learning about bugs or learning about birds. We have a couple sample activities on our program page. And we also have other resources available as well. And Science Action Club, we actually provide professional development for staff. So it includes an online training that is about 2 hours and goes through some of these protocols and every single activity and helps guide you through everything you need to know about citizen science, about clouds, about our different activities. And our guidebook is actually really helpful. Oh, it's kind of like blurry. This guidebook has about, all of our different activities. And there's 12 activities there with about many different lessons like games and icebreakers, and then a core lesson. And it's about for a 60 to 90 minute session. So 12 activities, 60 to 90 minute sessions that you can do in a semester with your group. And when you enroll with Science Action Club, you get access to that online training. You get this handy guidebook to walk you through all the activities, and you also get a full kit filled with all the materials that you need, all the scientific materials, including printouts and binoculars and the tools that you need for that specific scientific inquiry and STEM lesson. So it's really an all-inclusive package, and it's really exciting. We have some amazing success stories and folks who love this curriculum for the way it really guides you step by step, and kind of how I just did with practicing and getting students excited about citizen science. So if you want to also set up a time to chat with me or with someone on my team, you can email us at scienceactionclub@calacademy.org.
Thank you so much, Olivia, for taking the time out to show out-of-school time providers in North Carolina more about Science Action Club and citizen science. To learn more about Science Action Club, visit www.calacademy.org/SAC. Don't forget to like, share, and subscribe to our YouTube channel for more videos like this and others that we know you'll enjoy. Do you have an idea for a STEMinar or a webinar that you would love to see NCCAP cover? Well, comment below or check out our website at www.ncafterschool.org.